everyone, so today I want to explain about partial differential. So if a function has more than one independent variable, then the derivative of that function also has more than one derivative. So z equal to f x and y. So do z per do x. This is referred to the derivative of z with the variable x, and this one is derivative z with variable y. So the example is, find the partial derivative of the following function z equal to 2x power 3y plus y squared. So lower or x variable, so the z per do x is 2 times 3 x power 3 minus 1 y. So the answer is 6x squared y. So the second one is y variable, so do z per do y is 2 times 1x power 3 and y power 1 minus 1 plus 2y square minus 1. So this become y power 0, and everything powered by 0 is 1. So the result is 2x powered by 3 plus 2y. If it has a function z equal to f x, y, the total differential of the function is defined as dou z equal to dou x, dou z per dou x plus dou y, dou z per dou y. So we go to the example. If z equal to x power 3 minus xy squared plus y, so we're checking for this one. Dou z per dou x is 3x squared minus y squared. So we're searching for the second one is dou z per dou y is minus 2xy plus 1. So the dou z is 3x squared minus y squared dou x plus minus 2xy plus 1 dou y. Okay, so that's all from me. Thank you.
Hello everyone, now we will learn about the elasticity. The first one is elasticity of demand. The formula of elasticity of demand is elasticity price is equal to P per X times dx per d. So, the elasticity of demand measures the percentage change in the quantity demanded by consumer as a result of percentage change in the price of goods. Okay, next is how to determine that it is elastic or inelastic. We use the EP. We find the absolute value of EP. If it's more than 1, it means elastic. If it's less than 1, it's inelastic, and if it's equal with 1, it's unitary. Okay, Okay, and then from the real value, we can find that if the EP is more than 0 or positive, if the x increase, so the y will increase too. If the x decrease, the y will decrease also. And if the EP is less than 0 or negative, if the x is increased, the y will decrease. And if the x decrease, the y will increase. Okay, now we move to the example. The first question is the demand function for a good is QD equal to 25 minus 3p squared. What is the elasticity of demand at price level of p equal to 5? So first, we should find the first derivative of QD. The first derivative of QD is minus 6. Okay, the next step is we find the EP. The formula is EP equal with P per Q times the dq per P. Okay, we put this 5 in this formula. 5 per the Q is 25 minus 3p squared. 25 minus 3p squared times the first derivative of Q is minus 6p. Okay, so we know that the p is 5, so we change the p with 5. Okay, we will solve these equations. 5 per 25, 3 times 5 squared is 25 minus 75 times minus 30. 5 per 50 times minus 30 is equal with minus 150 times 50. I'm sorry, it's minus 2. So, the answer is 3. So the absolute value of EP is more than 1. So it means this function is elastic. The next one in elasticity is elasticity of supply. Actually, the conclusion of how we solve this equation is same with the elasticity of demand. So maybe we can move to the example. So So it's given the QS is minus 200 plus 7p squared, and the price is 10 and 15. So we should find the elasticity when the price is 10 and when the price is 15. The first step is we should find the first derivative of the Q. Okay, first we find the first we find the elasticity of supply if the price is equal with 10. The next step, we should find the first derivative of QS. The first derivative of QS is 14p. So now we find the EP. We change the p with 10, so 10 minus 200 plus 7 times 10 squared times 14 times 10 minus
500.
Kok jadi minus?
Enggak, plus 500.
Oh, 10 per 500 times 140. So 14 per 5 is equal with 2.8. So we should find the absolute value. The absolute value of this EP is more than 1. So it means it is elastic. Okay, now we find the P equal to 15. So the first before this, we find the first derivative of QRS, and now the first derivative of QS is 14p. So we find the EP. The P we change with 15. So 15 but the QS is minus 200 plus 7 times 15 squared times 14 times 15. So 15 per minus 200 plus 1575 times 210. So the answer is 2.3. So we find the absolute value of 2.3 is more than 1. So it means this is elastic. Okay, that's all from me. Thank you.
Hello everyone, today I will explain about optimization without constraint. And there is step-by-step for solve the problem. The first is to find the stationary point through the first derivative. And from this, we can find two equations for finding the points. The second step is we check the maximum or minimum values by determining the second derivative. And this is the formula, and the result is must more than 0. If the d is less than 0, we must to stop the work because it needs higher computation. Okay, next the example. TC is QA squared plus 9QB squared plus QA times QB, and the PA is 10 and PB is 40. The first question is calculate how many units of each must be produced for maximum profit, and the second question is calculate the maximum profit. Okay, the first we must search the TR first. TRA is PA times QA, or 10 times QA is 10Q, and TRB is PB times QB, or 40 times QB. Okay, the next is we search the fee or profit. We know that TR this one, and we put into this formula 10 QA plus 40 QB minus with the TC. The TC is QA squared plus 9QB squared plus QA times QB, and the result is minus QA squared minus 9QB squared plus 10QA plus 40QB and minus QA times QB. Okay, how to find the Q? We find the Q by the first derivative from the phi formula. Okay, the first derivative, the QA is 2QA minus 10 plus QB, and the first derivative from dou P per dou QB is 18 QB minus 40 plus QA. Okay, the next is we eliminate the first equation with the second equation. 2QA plus QB equal to 10, and QA plus 18 QB equal to 40. We eliminate the QA. We times the first equation with times with 1, and the second equation with times with 2. Next, we eliminate both of them. It's 35 QB equals to minus 70, and we find that QB is 70 per 35, and QB is equal to 2. Next, we substitute the QB to the first equation. We find that 2QA equal to minus QB plus 10, or 2QA is equal to minus 2 plus 10 2QA is equal to 8 and QA is 4. We can conclude that the stationary point when the profit is maximum is QA equal to 4 and QB equal to 2. We find the P maximum. The formula is TR minus C. The TR is 10QA plus 40QB minus QA square plus 9QB square plus QA times QB. Because we already find the Q, we put the Q into this formula. 10 times the QA is 4 plus 40 times the QB is 2 minus the QA is 4 square plus 9 times 2 square plus 4 times 2. Okay, so we find that 40 times 80 minus 16 plus 2 square times 9 is 36 plus 8. Okay, 40 plus 80 is 120 minus 16 plus 6 and 8. 12, 9, 5, 6 minus 60 and the result is 60 and find that the P maximum is 60. Okay, I think that's all from me. Thank you.
Hi everyone, my name is Zahara and today we're going to talk about matrix. So first of all, we have 3 matrix here. This is 2 times 2 matrix. Why is it 2 times 2? Because this is the row and this is a column. So how to write these is row times column. Let's see another example. So this have 2 columns and 3 rows, which means this is the row 3 and this is the column 2. Next, this matrix has 3 rows and 3 columns, which means this matrix is 3 times 3. But for today's video, we're going to study about 2 times 2 matrix. Okay, so now we're going to study about the additional and matrix 2 times 2. So the formula is A, B, C, D plus matrix E, F, G, H. If we plus them, so A plus E, B plus F, C plus G, and D plus H. Like so. So, for example, we have matrix 3, 2, 5, 7 plus matrix 6, 9, 8, 4. Which means 3 plus 6, 2 plus 9, 7 plus 4, and 5 plus 8. Which means the answer of this question is 9, 11, 11, and 13. Okay, so we're going to talk about subtraction in matrix. So as you can see, we have 2 matrices here. So how it works is matrix A and E, matrix B minus matrix F, matrix C minus matrix G, and matrix B minus matrix H. So we have an example here. So 3 minus 2, then 2 minus 5, 7 minus 6, and 5 minus 3. Which means the answer is 1, minus 3, 2, and 1.
Yeah.
So now we're going to talk about multiplication in matrix. So the formula is row times column. Okay, let's see. A times E plus B times G. Z row times column. Next, A times F, then B times H. Next, row times column, so C times E plus D times G. The next one is C times F plus D times H.
Thank you.
Okay, so let's move on to the example. So we have two matrices here, 1, 7, 2, 5 and 3, 1, 4, 6. So how to do it is 1 times 3 plus 7 times 4, then 1 times 1 plus 7 times 6, then 2 times 3 plus 5 times 4, then the last one is 2 times 1 plus 5 times 6. Okay, so we can get 3 plus 28, which means 31. Then 1 plus 42, which means 43. Then 6 plus 20 is 26. Then 2 plus 30 is 32. So now we're going to talk about transpose. So in transpose, the row turns into column and the column turns into row. Okay, for example, there is 1, 2, 5, 7. Let's say this is matrix A. So what is the A transpose? Okay, so how you do it is turn the row into column. So 1 and 2, 5 and 7. Okay, so we're going to talk about the determinant in matrix. So the formula is A times D minus B times C. Okay, for example, we have 2, 5, 7, 9 here. So let's find the determinant of it. So we use this A times D, so 2 times 9 minus 5 times 7, which means this is 18 minus 35, and the determinant of it is minus 17. We're going to talk about the inverse of a matrix. So let's start by the formula. So how to write inverse in matrix is A, the name of the matrix in this case is matrix A power minus 1. A power minus 1 or inverse equals 1 per determinant A and adjoint A. Okay, so what is adjoint A? Adjoint in the name of the matrix, in this case matrix A, is so let's say this is a matrix, okay? The name of the matrix is A. So the adjoint is you switch A and D equals this, D and A, and the C and B you only put minus. So that is how you find adjoint A. Okay, so let's move on to the example. Find the inverse of 4, 2, 5, 3. Okay, for the first step, we have to find the determinant of it. So, how to find the determinant of 4, 2, 5, 3 is 4 times 3 minus 5 times 2. In this case, the answer is 2. Okay, so let's stick to the formula 1 per determinant A, which means 1 per 2 times the adjoint of this matrix. So, let's see. To find the adjoint of this matrix, let's say this is matrix A. Okay, so the adjoint of matrix A is, let's stick to this formula. So A switched with D, so 3 and 4. Sorry, my bad. 3 times 3 and 4, and then 5 and 2, we only add minus, so minus 5 and minus 2. So, let's go here. So, 1 per 2, because 1 per determinant A, times the adjoint, so 3 minus 2 minus 5 and 4. Okay, so the answer is, just multiply it, 3 per 2, then minus 5 per 2, then minus 2 per 2, and 4 per 2. Then let's divide it all. So 3 per 2, then minus 5 per 2, minus 1, and 2. That's it. Okay, so that is all from me. Thank you!